Hello and welcome to the year of weather for 2018. My name's Mark Higgins from EUMETSAT and I'm going to talk you through this satellite animation of the entire year's weather. So as we start to look at the video, you'll see straight away at the beginning of the year we're seeing a cyclone just off the coast of Madagascar and another cyclone following the southern Indian Ocean. And you'll see these throughout the course of the year. We've put the names of the cyclones next to them so you can see just how active certain parts of the world are during certain parts of the year. So as we start, we're in January, it's the Northern Hemisphere winter, it's the Southern Hemisphere summer, so the sea surface temperatures is a bit warmer in the south, which is these energy for the cyclones you're seeing in the southern Indian Ocean. In the north, you're seeing this steady flow of storm systems travelling across towards the western coast of the United States of America, as well as storms travelling across the Atlantic and coming towards us in Europe. Just as you start looking at it, what you're looking at is the entire globe. So you're seeing what we can see from the geostationary orbits from several satellites around the world. So this is a collaboration between ourselves in Europe, the US and Japan, and all of this data has been put together by the French weather service Météo France. So we're really grateful for them for all of their work in putting this together. You'll see that the dominant weather patterns as you're looking towards the north and towards the south, the weather moves from the west towards the east. So these storm systems just travelling around. You get a slightly different view. If you look at the equator, you can see this sort of pulsating view. Now what we're looking at is the infrared view of all of the Earth's clouds during the course of each day. And you can see this pulsation is what we call a diurnal cycle, so the daily variation. So as the ground heats up, it gives these clouds energy and it forces them upwards, and they then rise and then decay later on. That brightness is the coolness. So the brighter the cloud, the colder the cloud, and therefore the higher the cloud. So these clouds in the equator, you're seeing the really high clouds coming up, and they're usually got strong rain underneath, possibly some hail. These really big kind of tropical storm systems. What we've been showing you up till the 1st of April is 8 images a day, so an image every 3 hours. What we've been able to do after the 1st of April is move to showing you data every half an hour. So this is to do with an upgrade in some of the satellites that have been put in place around the world. So you're now seeing images every half an hour. And this gives you a sense of the sheer volume of data that we give to weather forecasters around the world so that they can work out, right, what's the weather doing right now and what's it going to do in the immediate future. So what we call nowcasting, forecast for particularly time-sensitive circumstances. For example, if you're looking at rail infrastructure or road infrastructure, or particularly aviation, where quick changes in the weather can make a big difference. So what we're showing you in these infrared images is just the clouds and what's going on there. But with all the satellites, we have much more information. We can actually get information about how much dust is getting lifted up into the atmosphere. We can look at the volcanic ash content or the SO2 clouds associated with the volcanic ash. So the satellites we use to monitor the entire Earth's environmental system. Historically, when people navigated the world using ships and sailing, where the strongest winds were and where you were going to most be able to travel across the Earth. Now, of course, in those times, you wouldn't have had a satellite view of the Earth, and so those storm systems where the cyclones were, wouldn't have been known. So the number of accidents and catastrophes that happened with shipping is one of the things that drove the improvement in weather forecasting. So in about the 1850s, there was a few shipping accidents that happened that really drove people to set up weather services and communicate weather warnings. But it wasn't until the early 60s, 1960, that the satellite era really started. And from then, we've been able to see this global view of the Earth and to see where the big storms are all the time. So up until then, a big storm, a big cyclone could hide. Now it's not possible, and you're going to get a warning wherever you are. So looking at the equator, you can see this band of active weather. It actually moves north and south during the year with the heating of the sun. So as we move towards the southern hemisphere summer, at the beginning of the year, you see the storm system or this belt will be lower down. It's the intertropical convergence zone, we call it. It's where air from the north and south meets and then rises. It's where you've got this real potential for rising, and it's this rising that causes the storms. And as we move towards the northern hemisphere summer, it of course then travels further north. We're now moving into the Atlantic hurricane season. And what you can see is air flowing off the west coast of Africa. These little low pressure centres get formed, and sometimes they'll get a little bit of rotation and start to spin. At that point, you've got the potential to form a hurricane. With the sea surface temperature, you can then feed that hurricane and give it some energy, and it can then start to establish itself through a rise in the centre of the storm that then dissipates out at the top, and the air then descends around, and it's all rotating. And once that's actually started and got going and is nice and stable, you can actually have a very big storm that will travel across from West Africa to the middle of the Atlantic. And it can then do one of two things. It can then travel across towards the US seaboard or through the Caribbean islands, or then travel back across to Europe. And you'll see some of these storms doing that. So we'll just follow some of these storms as they travel across from West Africa. So here's Hurricane Florence. It started out of West Africa, it's now travelling across. And at this point, the forecasters are thinking, okay, where is it going to make landfall? This storm, it looks like it might travel up towards Europe, or it might travel up towards the US. And it actually makes landfall in the US, but very far north. It's followed quite closely by Hurricane Helene, which actually travels over, and it makes what we call the extratropical transition. So it loses some of its energy as it travels into the cooler waters of the North Atlantic, but then travels across towards Europe and becomes quite a strong storm. You'll notice the storm patterns, they have a natural rotation. So the Earth's atmosphere is of course connected by gravity to the Earth, and the Earth is spinning. And so it's the spinning nature of the Earth that passes some of that rotation into the storm systems. So what we see is in the northern hemisphere, these storm systems, they have an anti-clockwise rotation to them, and in the southern hemisphere, a clockwise rotation to them. And that fits with the rotation of the Earth. So rotation moves from the equator towards the pole and then back again. And it's called the Coriolis effect, and it gets stronger as you move away from the equator, which is why you see it in those northern and southern storm areas. As we move towards the end of October, we're seeing the Atlantic storm system die down, but you'll still see some of these cyclones around the world. So here in EUMETSAT, we take most care over our member states, which come from Europe, and that's why we have a particular Atlantic European focus. We also provide a lot of weather information to Africa, which can be seen from our satellites really quite clearly. So you'll still see other areas of the world that are active. So for example, here, November the 19th, we can still see a lot of activity in the eastern part of the Pacific Ocean. So storm systems moving across towards the Philippines, towards eastern China, and up towards Japan. Some of these huge, great tropical cyclones, the typhoons. So we've really hoped you've enjoyed watching the world of weather for 2018. Have a look again and choose one particular part of the world. Where's the weather coming from for that place? What's driving it? You can see the seasonal changes, the seasonal patterns. It's a wonderful thing to look at, and it's a real privilege to be involved in such an international cooperation. So it's taken several agencies to bring their data together, and this data is available to weather forecasters around the world 24 hours a day, 365 days a year.